We have here the CADET II board, also known as an electronic circuit trainer. These boards can be located in Haggerty Hall, room 365, as well as in the Open Lab, room 379. This video will cover an overview of all the functionality that can be useful to you in digital electronics, EECE 112.
The first thing you should know about the CADET II board is how to turn it on. You can find the power switch at the back of the board.
Next, you should know that the CADET II board is independently powered. As such, it provides 3 voltage sources, a positive 5-volt source, and 2 variable sources for use in your digital circuits. The variable source can be set with these 2 knobs. The voltage will vary between 1.3 and 15 volts. In the top left corner, we find the function generator. It is useful for providing your circuit with a clock signal. In configuring the wave, you should first choose which waveform you would like to use. The CADET II board provides sine, triangle, square, and TTL waveforms. For your digital circuit, the TTL waveform is the most appropriate because it is a square wave with a minimum of 0 volts and a maximum of 5 volts. After you select the waveform, you must set the frequency of the wave. The left knob and the center knob control the frequency. The left knob multiplies the setting of the upper knob. For example, setting the upper knob to 10K and setting the left knob to 5/10 will produce a frequency of 5 kHz. If we increase the frequency of the left knob to 8/10, we will then produce a frequency of 8 kHz. Finally, you can use the right knob to set the amplitude of the wave anywhere from 1 volt to 10 volts. Below the function generator, we have the debounce push buttons. These buttons are useful for applying a user-defined input signal to your circuit. The push buttons are essentially grounding switches which have 2 modes of operation, a normally closed path to ground and a normally open path to ground. In a configuration using the normally closed nodes, the nodes are grounded when the push button is up. When the push button is pressed, the connection to ground is opened. Alternatively, in a configuration using the normally open nodes, the nodes are only grounded when the push button is pressed. At all other times, they remain open from ground. These push buttons are useful for operations such as advancing the logic state of your circuit. The logic switches are also useful for providing a user-defined input signal. There are 8 switches, which can be set to provide a logic level 0 or logic level 1. The value of logic level 1 can be either positive 5 volts or positive V, which can be set at the top of the board. The potentiometers, located at the bottom center of the board, provide a variable resistance. One provides resistance from 0 to 10 kiloohms and the other 0 to 1 kiloohm. The BCD 7-segment display provides the ability to represent binary input in decimal form. The 2 digits on the board, 1 and 2, are independent of each other. That is, they have independent inputs. Still, both displays respond to input in the same manner. Notice the 4 rows ranging from A to D. A represents the least significant binary digit, while D represents the most significant binary digit. A 5-volt input, or high input, gives a logic 1, and a grounded input, or low input, gives a logic 0. So take digit 2 for example. Connecting 5 volts to row A and row D will produce a 9 on the display. As a note to the user, that's similar to a breadboard, each row is tied together as a single node. The logic probe, located above the 7-segment displays, is useful for troubleshooting your digital circuit. To use the probe, connect the VCC node to the same value of logic 1 being used in your circuit. Most often, this will be 5 volts. Then, connect the input node to the node on your breadboard that you want to test. The bottom switch allows you to test either CMOS integrated circuits or TTL integrated circuits. The top switch allows you to view the change in the value you are testing. Set to pulse, the pulse LED will flash when the input changes. When set to MEM, a change in the input will cause the pulse LED to remain lit. The 8-channel logic monitor, located at the upper right of the board, is an array of 8 channels used for testing the output of your digital circuit. The red LEDs signify a logic level 1, which can be set to either positive 5 volts or positive V being set at the top of the board. The green LEDs signify a logic level 0, which is typically ground. The monitor also allows you to define what type of integrated circuit you are testing, TTL or CMOS. So now you know a little bit more about the functionalities of the CADET II board. If you would like to see this in practical use, please go on to video 3. If you would like to know more about building a circuit on your breadboard, please see video 2. Thanks for watching.
Technologic, buy it, use it, break it, fix it, trash it,